Hi, welcome to part 2 in this series in which I'm discussing how to build a stack that involves ReactJS and GraphQL. Part 2 is going to concentrate on building the ReactJS side of things, and what we're going to do is we're going to create a ReactJS application, set up dependencies for ReactJS, GraphQL, Apollo, Typescript, and a code generator tool that I use for translating queries and schemas into ReactJS hooks. And there'll be a fair amount of configuration work to get all those things to work together. Once that's been done, we'll finish off with a little bit of code that will use a GraphQL query to pull the to-dos from our previous ReactJS GraphQL server, and it will put that data onto the screen. So let's get started. So let's create our React application. And we want to create a React application that supports TypeScript, which is made really easy now through Create React App. Before we do that, the project that we're working on, we said we're going to use Yarn workspaces to handle dependencies for sub-packages and sub-projects within it. We're about to add a new sub-package client, so let's add it to workspaces first, and that way when it gets the dependencies, it will look for common dependencies and store them in the top level. And then the next thing is we just run the create React app prompt. So npx means we can run anything. Create React app. We're going to call it client because it'll create a new folder called client, and that's how we want to organize our code. And we use the TypeScript option to say that we're going to create a TypeScript project, and off it goes. Now this is going to go and fetch React and a whole bunch of different things, including some dependency libraries that we could use. So it's going to get the type libraries for Node and the type libraries for React. It's going to leave a few out that we're going to need later, like React Router, but the stuff that we need to get started is there now. And we'll add some more dependencies in a moment that will bring in the files that we need for GraphQL and Apollo and all those other libraries that we mentioned. So we're almost done. Let me see how it's done doing picking files. So yeah, really pulled everything down. It's running its script. It brings in a simple application and it's done. So if I now look in this project, I have a complete React application that will run. And under its source folder, there's a whole bunch of files. Now, I don't want all of these, so I'm going to do a quick clean out. The first thing it creates is an app. And I don't need the big fancy logo and everything, so I'm just going to get rid of this and say hello world. I don't want to bring in the CSS or the logo, I'm not too bothered about those. I'm not going to bring in the tests and get rid of those bits there. In the index file, it has this service workers thing. Nobody uses this, and to be honest, just get rid of it because it makes your life more difficult. It means that when you refresh a page, it doesn't pull the latest version, but then the next refresh, it does. So I'm going to get rid of service workers as well. So now I've got a bare bones React application, and if I go into my client and do yarn start, it will bring up that server. So it brings up a Webpack dev server, which means that whenever you make any changes, they automatically get updated. And let's see if I've got a browser around here somewhere. So here we have a look. Localhost 3000. Yours will probably bring up the browser automatically. There we go. Hello world. So now we're going to need to add some dependencies so that we can make calls to GraphQL. And also bring in a couple of other things that are going to help us. So we're going to need to bring in, let's go to our client, because we need to add these dependencies in the client, not at the top level. We're going to use yarn add, and I'm going to need Apollo boost. I'm going to need GraphQL. Apollo boost is going to bring in a whole bunch of stuff for us. I'm going to need React Apollo to be able to use the Apollo client code with ReactJS. Apollo APP. I'm going to use React Apollo Hooks. It's a help library that will allow us to use hooks rather than having to use higher order components or components, which is really useful. We've already got Typescript, so that should be that for dependencies. I also need to add some dependencies at the top level. I'm going to set up this code generator tool I've talked about, which will be scanning the schema from the server and queries from the client, and then putting those into a generated file within the client itself. So let me just see what I need to bring in for that. This one's going to need quite a lot of dependencies. Let me just show you what I'm going to use. So I need to bring in GraphQL, a GraphQL compiler, some GraphQL code gen dependencies, and these are the ones that we're using to do the code generation, and also some React Apollo stuff. So let me just add that. The -w is because I'm at the top level of the project, and you have to use that, otherwise it'll complain, because this is a workspace, and that's just how workspaces work. So that just comes in. Right, so we've got all dependencies there. So in the next step, we need to set up the code generator, and we need to instantiate the GraphQL client within the React application. So the code generator tool is used to analyze the schema and your queries, and it will output then a TypeScript file that includes types and hooks for the different queries that you've got. It also gives you components and a few other things as well, but we're just going to use types and hooks for this. But before it can do all that, you need to configure it to tell it a bit about your setup. So in this instance, I'll get rid of that and that. We're going to set up a file that holds that configuration. Then it expects a file that's called codegen.yml. So codegen.yml, a YAML file. And in that, we're going to tell it a little bit about how to go about generating things. So I'm telling it that I want to overwrite any existing file every time it runs, so it always wipes it out and creates a clean one. I'm giving it the path to the schema that we're using to store our GraphQL schema, and the document section is describing where all the queries are that it's going to generate code for. And then this next section here is actually used to define what it's going to generate, because CodeGen is quite modular. And it doesn't just work with React, and it doesn't just work with TypeScript. It also supports regular JavaScript. It supports other front-end frameworks, and it even supports back-end code as well, and the fact that it will generate MongoDB definitions for your schema. But in this instance, we're only interested in capturing code for TypeScript and the operations that we need to carry out what we want to do. And also we need to tell it that we're using React Apollo. The extra piece for ESLint disable is due to a bug or a feature of Create React App. Create React App, when it's compiling your TypeScript, uses its own linting configuration to check to make sure that the code is good. The issue there is that it doesn't let you define your own, it doesn't let you override it, and within the code that gets generated by this tool, it puts import statements part the way through because it's modular, and that's just how it works. And Create React App doesn't like that at all. So what happens is we add this line in here, and in the TypeScript file that gets generated, it will put at the very top of the file the ESLint disable instruction. So when it gets run through the compiler with Create React App, it ignores the file that it generates, and we don't get any errors. Otherwise, it stops your build from working, and you can't even use it. The other piece of configuration is, by default, you don't get hooks generated, but luckily the CodeGen application knows about this particular library that we're using for ReactJS Hooks with GraphQL, so you can opt in to use that. So that's what we've done here. So we've got a CodeGen set up. Now we need to set things up so that it will run CodeGen, and thankfully CodeGen's got a watch command in there, so we'll be able to use that to be able to run our back end, our front end, and run the code generator to make sure that it always updates the generated code according to the queries that we've written. I'm going to set up the top level package definition so that I want to add a start and a dev method to that so that we can run the front end and the back end both at the same time, and we can also run the code generator in watch mode. So look at my dependencies at the moment. I'm going to use a tool called concurrency. Concurrency lets you run multiple scripts at the same time, and it's operating system agnostic. So I can use this and run this on Windows, and I can run it in Mac, and I can run it in Linux, and it runs equally well on all of them. So I need, before I do anything else, I need to find out why my terminal's not working. Right, it's not going to work, so let's just create a new one and see if that works. Right, so from the top level, I want to use yarn add, and I'm going to add concurrency. And I'm going to set up some scripts so that we can set these things in motion. So scripts, and as usual, I have one I prepared earlier, so I'm going to pull that in, which gives us all the different features that we want. So I've set up some scripts here for running the server from the top level, running the client from the top level, and then if I run in dev mode, I'm using concurrently to run the server, the client, and the code gen. And I've got setups there to be able to do that. GraphQL code gen. I just want to double check that those work. Yarn code gen. Yep. And that allows me then to run the front end and back end. Concurrently, command not found. And just check that we added that yarn. Add concurrently. Yarn dev. Right, there we go. Server and backend all running in one go. So now I can set up the GraphQL client, and that will help me get things talking to the server. To get ReactJS to talk to the server, I'm using a library called Apollo GraphQL client, from the same people that wrote the server software that we're using as well. But to make that work, I need to set up a instance of the client, and I need to tell it where to get its data from. So if I go back into my client application, all the kind of like plumbing stuff tends to go into my index file. So if I open that and pull up an example I got from earlier on. Right, so I'm going to need to use Apollo client. So I'm going to need to use Apollo client, and I'm going to need to use the Apollo provider that the React Apollo Hooks library provides me. This is documented on the React Apollo Hooks website. It is literally just a cut and paste job from that. And I then need to create an instance of a client. So in this instance, I'm saying, right, create me a new Apollo GraphQL client, and all the queries will go to /GraphQL on the same server that the React application is running on. Then all that's left to do is I need to create a context that will hold all the Apollo GraphQL and hook information. So if I go back to my app, I'm going to need to change that to add a context. I put a context around my app, don't I? Yeah, so so much red. Thank God for automatic formatting of code, huh? Okay, so now I create a Apollo provider, so I'm creating a context for my Apollo stuff, and that just requires one parameter, and that's client. And then that wraps my whole application. So now my whole application has access to the Apollo client. So now I have my automatic code generator working that's looking for queries to process and translate. And I've got my Apollo GraphQL client wired in, so I've got a context that stores how to get to the server. The only thing left to do now is to actually write a query. So let's try and do that. So I say I've got my app here, so let's do it in the app at the moment, and then we can refactor out into something later on. So instead of saying hello world, I now want to say to-do list. And here I want to put in some to-dos. And it's probably going to be a list. So I just need to figure out how I'm going to get those in there. So the way it's going to work is, because we're using this automatic code generator, I can write queries just like regular GraphQL queries. So if I go back to my playground that I had running before, I have a simple query here that gets me to-dos. So I just want to lift and shift this. I just want to cut and paste it into my project. So looking at my project, I want to create a queries folder to keep all my stuff together. I keep all my queries and all my GraphQL stuff under a GraphQL folder, because later on you'll find that when you do mutations, you need to be aware of what queries may need to be rerun to populate the cache, or you may just want to see what queries there are, because sometimes you'll find you've got 3 or 4 queries that are all almost identical, and you want to make sure you don't have duplications. So I'm going to create my queries, and I want to create a to-do list. And you have to name each of your queries to allow you to easily call them from different things, and also to help it with the cache. So I'm going to call it to-do list. And to-do list will get back a list of to-dos. With my query in place, how do I get my data? So back in our application, the first thing I need to do is I need to somehow get hold of this file that has been generated. So I'm going to import from GraphQL index. In that index TSX file, I should have something I can use, and the generator follows a convention. Anything that's a hook starts with use, then it's the name of the query, and then it's either query for query or mutation for mutation. So here I'm going to use to-do list query. And in my code, I'm not sure if you've used hooks before, but they can feel a bit strange to begin with. But the idea is that I can call a function that will return back an object, and the values for the properties in the object will change as things happen. So I know for a fact that I'm going to get back data, error, or loading as the properties that come back. And they're going to come back from use to-do list query. And I'm not setting any parameters or any options, so I can just use that simple format. Now I need to actually specify how I'm going to handle those properties. So I can say if loading is true, then return a message to say that we're currently loading. And if error for some reason is true, I can return something that tells me a bit about the error. And I'm starting to get autocomplete now. This is all coming from the Typescript type definitions that get generated. I can also say if data, or if not data, if there's nothing in data and there's we're not loading, there's no errors, so it's something bizarre. And no data dot to-dos. So if there's no to-dos and no data, which shouldn't happen, then no data. So I've checked to see that I'm not loading, I've checked to see there's no errors, I've checked to see there's data. Now I can actually go ahead and get my to-dos from the data object that gets returned back. And I know that it's called to-dos because it's telling me in the autocomplete, but also because in the query it's called to-dos. So all that's left is putting this on the screen. So we're going to map through the to-dos, and each time round I'm going to get a to-do, and I would like to return a simple line. So to-do dot ID, so I'm getting autocomplete again, and to-do dot title. I could, if I wanted to, I could expand that out in here as well. Both ways work equally well. I could simply do ID and title. And again, I'm getting autocomplete when I do that because it knows type information. And this is the really useful thing. That type information is coming from a combination of this query and the schema file that we had back in the back end. So it gets these types out of this for me and gives me autocomplete. So I can write a query, and then when I write the front-end code to put the values on the screen, I don't need to go look at the schema, and I don't need to look at the query. I've got it at my fingertips, and that really helps build things quickly. It also shows up if I'm doing typos to make sure that I'm actually using the right property names. So I've got my to-dos. So again, alright, so we've got one error. That should be fairly easy to fix. Yeah, it doesn't, I'm using the wrong brackets. Here we go. So I've got my to-dos, and if I look at my network tab, I can see that it made a GraphQL call, and I can see the data that came back. And if you've installed the Apollo dev tools, which is a good idea, you can start to explore what it has. And for instance, here I can see that it has a cache, and I can see the things that are stored in the cache. So that's the end of part 2. Hopefully demonstrated that it's really easy to build GraphQL queries and then use them in your ReactJS code with autocomplete for free. And the configuration work we did there is relatively simple, and you'd be able to reuse that for any applications that you're creating. So part 3 is next, and in that I'm going to add Formic to show how you would use Formic to build a form and populate it with data from your query, and then how you'd use a mutation to save changes back up to the server, which is just a function call. If you've got any ideas or any comments, please leave them below, and I look forward to speaking to you on the next episode.